Hello everyone, we are Team Smashers. Today we are going to present on the paper Multilingual Machine Translation with LLMs, Empirical Results and Analysis. The motivation behind this work is bridging the global language gap. There is an increasing demand for communication across diverse languages, but low resource languages don't have enough parallel data for traditional translation systems. Large language models like GPT-4 show emergent translation capabilities even without large training datasets. However, there is a strong need for systematic evaluation across many languages to really access the performance. Traditional supervised machine translation systems such as M2M100, NLLB, and Google Translate perform remarkably well when trained on massive amounts of parallel data. However, they degrade significantly on rare or low resource language pairs. These highlight the limitations of data hungry supervised approaches and sets the stage for exploring LLMs. Recent research has explored LLMs such as Bloom's, XGLM, and GPT-4 for translation in zero-shot or few-shot settings. Bloom's demonstrated early multilingual ability, XGLM was tested for cross-lingual understandings, and GPT-4 showed strong emergent translation skills. But earlier studies often focused on high-resource languages and lacked large-scale comparisons with strong supervised baselines. This is the gap the paper addresses.
So coming to how this paper differs because of its scale and depth. Previously, studies looked at only at just few languages, but this one covers around 102 languages and 606 translation directions, making it the biggest evaluation yet. It also compares LLMs not just for each other, but also with strongest baselines like NLLB, M2M100, and Google Translate, which gives us a complete performance picture. In terms of tasks, older works mostly focused on high resource languages in zero shot mode, but this study also looks at few shot and cross-lingual cases, giving us some more insightful data. And unlike earlier limited studies, this one provides new findings on how examples and instructions affect performance so that it can guide us for the future LLM research. Now coming to key contributions of this research. Firstly, it builds the biggest benchmark so far, testing 8 LLM models on 102 languages and more than 600 translation directions. Secondly, it shows that GPT-4 does really well. It even beats NLLB in about 41% of cases. Third, the paper shows that LLMs have zero resource ability. They can still translate even when they haven't seen training data for a language. Fourth, it finds that the examples we give matter more than the instructions and prompt. Fifth, coming to cross-lingual examples, like using German-English examples to help English-Chinese work done, especially work well for low-resource languages. And finally, it offers useful baselines and guidance that will help us in future research in multilingual translation.
This paper presents a rigorous experimental setup to evaluate LLMs in multilingual machine translation. For model selection, the author benchmarked 8 LLMs including ChatGPT, Llama 2 and GPT-4 and compared them with strong supervised baselines like M2M100, NLLB and Google Translate. They use Florius 101 covering 102 languages and 606 translation directions, pivoting around English, French, and Chinese to include high, medium, and low resource languages. In terms of prompting, they tested multiple templates to study how phrasing affects translation. The tasks include zero shot, few shot, and a novel cross-lingual exemplar setup, where examples from one language pair were used to add translation in another. For evaluation, both automatic metrics like Blue and Comet and targeted human checks were applied. The study also maintained strict experimental control, ensuring fair comparison across models. Overall, this multifaceted design provides a comprehensive picture of LLM's strength and limitation in multilingual translation.
Now we'll talk about key experimental results. LLMs are steadily improving at multilingual translation. For example, Llama 2 outperforms previously released open source LLMs and GPT-4 surpasses ChatGPT. Overall, GPT-4 is the best translator amongst evaluated LLMs, and it achieved the highest average blue and comet scores on most directions. LLMs translate into English far better than into other languages, performing strongest on English similar families, example Germanic, but struggles with distant ones, example Sino-Tibetan. Even GPT-4 shows clear weaknesses on non-English centric translations like French or Chinese centric tasks. LLMs like GPT-4 sometimes surpasses supervised model, beating NLLB in 40.91% directions, but they still fall behind on low resource languages where NLLB and especially Google Translate remain strong. Now we'll be analyzing factors that influence LLM's translation performance. And for that, we have chosen XGLM with 7.5 billion parameters. The reason for choosing XGLM were that it is first a medium-sized LLM and another it is open source. So we avoid the consequences of choosing a large-sized LLM and a closed source one. So first is the findings on pre-training corpus size. So LLMs can learn translation resource effectively, as shown by XGLM. Even with very little non-English data, that was less than 1% of English, it produces reasonable translations for low resource languages, example Catalan and Swahili, and even handle unseen languages, example Occitan and Asturian via in-context learning. Second is the findings on in-context templates. So LLM's translation performance is highly sensitive to templates with gaps up to 16 blue. Yet even task unrelated templates, example summarized as, can still produce good translation, showing that LLMs rely more on exemplar patterns than on explicit instructions. And no universal template works best across all cases. So thank you. That concludes my part. And now I will hand it over to Vinay, who will take you to the next part of the presentation.
So, analyzing factor influencing LLM translations. Finding on in context exemplars, cross-lingual helps low resource but hurts in high resources. And you can see best with 1 to 8 examples, but too many or duplicates reduce the quality. And also, sentence level, diverse and accurate examples are crucial. As you can see in a graph, exemplar number 1 to 8 is best, but and too many or duplicates reduce the quality. In context exemplar, mismatch translation consistency is low but diversity is high. In word level translation, consistency is good, diversity is good, granularity is lowest. Sentence level translations, consistency, diversity, and granularity is good. Okay, now we see future works and novel extensions. There are 4 points: adaptation for low resource languages, hybrid pipelines, automated exemplar retrieval, and robustness and ethics. So, the first one is exploring fine tuning with help of LoRa techniques for better performance and endangered and low resource languages. So, the next one is developing advanced pipelines that re rank, assembles, or cascade LLMs outputs with supervised machine translation systems. Third one is implementing intelligent system for automated selection of optimal exemplars like using BM25, semantic similarity, and entropy based methods. The final is robustness and ethics, a comprehensive evaluation for fairness, bias, and cultural sensitivity in LLM translations. This research lays the groundwork for more advanced, inclusive, and ethical multilingual machine translation systems.
So in the experimental plan part, we will going to start in month one. Our goal is to set a strong foundation. We will collect a small parallel data set for Marathi, English, Tamil, English, set up a baseline model like Indel Trans 2 and evaluate with the blue and comet score to compare with the state of the art model. And this will give us clear picture of where the baseline succeed and where they fail. And in month 2, we will focus on the target enhancement, first by adding short document context, 2 or 3 sentences at a time. We aim to improve the coherence, and second, we introduce a curated lexicon of about 100 domain specific terms. Ensuring consistency terminology, both enhancement will be tested separately against the baseline to measure their impact. And finally, in month 3, we will bring everything together. We will combine context, lexicon, constraint into a model, run analysis, looking at the pronouns, terminology, name entities, prepare a small demo, a script that translates a simple document. We will also summarize our findings in a concise report and along with the open source test set and results. Thank you.